All right, guys, today we're going to be talking about writing the equation of a line in slope-intercept form. So let's start by putting today's date in the top right corner. Okay, on Monday, we started talking about slope. What was slope? How did we define slope?
A measure of the steepness of a line ratio of change in y to change in x.
All right, good. The ratio of change in y to change in x. Okay, the ratio of change in y to change in x. Now we did say, Maddie's right, we did talk about how it measures the steepness of a line, but we want to have a more algebraic approach. Rather than a simple understanding, we want to have the algebraic understanding. Okay, now, I did also say there was a little thing you could use to remember. Okay, a little trick you could use to remember what slope is. See? Rise over run. Okay, now what was the formula? What was the formula for slope? Stephen? Uh-oh, Steve. Y2 minus Y1 over X2 minus X1. You got to have the Y's on top. Remember, it's a ratio, which means it's a fraction. So the ratio of change in Y to change in X, we got to have the Y's on top, the X's on the bottom. Okay, now, if I want to find the slope of a line passing through these 2 points, okay, passing through the point A, which is negative 2, 3, and point B, which is 6, 8. Okay, first off, every time I use any formula, we write that formula down. Y2 minus Y1 over X2 minus X1. Now, what else do we want to make sure we do before we do anything else? We want to label those points. We want to label those points with those variables. Good. So how would I label negative 2, 3?
Negative 2 would be x, and then 3 would be y, and then 6 would be x, and then y would be y, or 8 would be y2.
Okay. Now these wouldn't just be x and y. They'd be
X1
good, x1 and y1. Okay, good. So we label the points. We write the formula. Okay, now what? Got the points labeled. Who haven't I heard from yet? Logan. Sub them into the equation. So we would have m equals, my y2 is 8, minus my y1 is 3, over my x2 is 6, minus my x1 is negative 2. And then we simplify. Well, 8 minus 3 gives me 5. And what happens when I have minus a negative? Seth? Good. It becomes plus plus. So 6 plus 2 is 8. So the slope of that line is m equals 5/8. Okay, and that's what we were talking about last time, on Monday. Talking about the slope of a line. Now, today, we're going to add another part to this equation. We're going to add what's called the y-intercept. Y-intercept. Now, on a graph, what are the y-coordinates? What do the y-coordinates tell you on the coordinate plane? They tell you the vertical shift. They tell you up and down. Tell you how far to move, upward or downward. Okay, so along those same lines, what's the y-axis? The y-axis. Okay, it's the vertical line in the middle of the graph. The y-axis and the x-axis come together at 0, 0. The y-intercept, if you have a graph, the y-intercept is the point 0, B. Okay, so we have an ordered pair, 0, B. where a function crosses the y-axis. It's the point 0b where a function crosses the y-axis. Okay, now something I want to point out. At the y-intercept, x is always going to be 0. It's the point 0b because in order to hit that y-axis, the x-coordinate has to be 0. So the x-coordinate is 0. It's the point where the function crosses the y-axis. Now, next up, we're going to take the y-intercept and the slope, and we're going to use them together to write the equation of a line in, I know it says point-slope form, but it should say slope-intercept form. I know it says point-slope. That's something else. You'll learn about that one later on. Okay, it should be slope-intercept form. Now, if we have the graph, we've already talked about how to find the slope from a graph. We can either count or we can use the formula. And if we have the graph, we can also determine where that function crosses the y-axis. Now, if we have both of those pieces, we can write slope-intercept form, which looks like this. Y equals mx plus b. Y equals mx plus b. Now, if you think back to when we did proportions, and we had that proportion equation, y equals kx, remember how we didn't sub anything in for x or y. We found the value of k, say 5, and we had the equation y equals 5x. We kept y and x. We're going to do the same thing here. We are, however, going to substitute in place of m and in place of b. Well, what do you think we're going to put in place of m? I'll give you a hint. I picked that letter for a reason. Abby? Slope. Now let's put on our math brains and remember that mathematicians are not creative when it comes to naming things. So if this equation is called slope-intercept form and m is the slope, what do you think b is? Michael? It's the y-intercept. Okay? And it comes from right here. Okay, it's where that function crosses the y-axis. Okay, and that's where how we're going to make point-slope form based on the graph. Okay, we'll find the slope. We'll decide what the intercept is, what the y-intercept is, and we'll sub those points, those numbers, into the graph, or excuse me, into the function. So for these examples, I want to write the equation in point-slope form for each of the lines graphed below. So where I'm going to start is I'm going to pick a couple of points on the graph. That's what's going to make my job easy. So let's take this point, okay, 0, 2, and let's use this point, 4, 4. Now I know that I'm going to use those to find slope. So I'll write the formula down. And what else did we say we do with those points? At the start, every single time, how did we start? Stephen? Label those points. So let's call 0 x1 and 2 will be y1. And then 4, 4 will be x2, y2. Okay, now let's take those numbers and let's sub those in. So my y2 is 4 minus my y1 is 2 over. My x2 is 4 minus my x1 is 0. So I have 4 minus 2 is 2 over 4 minus 4 minus 0 is 4, which means the slope is 1/2. Okay? So I have the slope, so I can say y equals 1/2 x plus b. Well, what's b? B is the point where the function crosses the y-axis. So right here, my x is 0, my y is 2. So the b is 2. So y equals 1/2 x plus 2 is the slope-intercept form for the equation of this line. Okay, now let's look at number 2, and let's do the exact same thing. We'll start by picking a couple of points. Now, because we're trying to make the function in slope-intercept form, we need the y-intercept. So I am always going to try to make that one of my points. Okay, so I'll look at the y-axis, and I see that the function crosses the y-axis right here. So that's one of the points that I want to use. That's the point 0, -1. And then we can use any point we want outside of that. Well, I will look along the line until I find a spot where that line is right on the grid, okay, where I can clearly count to what those points are, what those coordinates are. And this one is 3, -5. Double check. 1, 2, 3. 1, 2, 3, 4, 5. Yep, 3, -5. Now, I know that I'm going to use the slope formula. I know that I'll have m equals y2 minus y1 over x2 minus x1. So I know I need to label those points. Well, Callie, how will I label 0, -1? Good. x1, y1. And Callie, how about 3, -5? Good. x2 and y2. All right, Willow, can you take those and sub them in here? That's okay. That's okay. 3 minus 0. Okay? So I have m equals y2 minus y1 over x2 minus x1. My y2 is -5. My y1 is -1. My x2 is 3. My x1 is 0. Well, now we can simplify. Okay, Will, a chance to redeem yourself. Minus a negative means what? Add a positive. And -5 plus 1? -4. And 3 minus 0? Other way around? 3. Okay, so I have my slope equals -4/3. Now, it can be an improper fraction. That's fine. We talked about that last time. Improper fractions are better for slopes than mixed numbers. Now, I also need my y-intercept. Okay, what's my y-intercept here? What is b, Ryan? -1. So we can say y equals -4/3 x plus -1. Now, there is one little thing that we would do here to clean this up a little bit. And it's not exactly changing the answer, but it is making the equation a little more streamlined, a little more what we want it to be, a little cleaner. Ryan? We wouldn't take out the negative. We can't just say plus 1. B? I could put parentheses around -1, but there's something else I could do even better. Alyssa? I can't make them both positive. Hey, say again? Okay, tell me what to write. Good. -1. We can change plus a negative to minus. Okay, plus a negative we can change to minus. Remember that. We've been doing that for a while, guys. If you see plus a negative, we don't like to have those two right next to each other. Okay? So we say plus a negative, that's moving to the left. Subtraction moves to the left. All right, let's take a look at number 3. Okay, let's start off the same way. Let's pick some points, and let's label some coordinates. So, Josh, can you give me a point? Tell me the coordinates of one of the points you would use. Not 0, 1. Look a little closer. Callie, can you give him a hand? 0, 2. Okay, look a little closer, Josh. You'll see 0, 2. Okay? And B, can you give me another one? 4, 3. There we go. Got me really confused for a second there. 4, 3. Good. Now, Heron, what should I do with those 2 points? I should label them. Okay, Heron, how do you want to label 0, 2? Good? Good? Keep going. Very good. X1, Y1, X2, Y2. All right. Now what, Mario? What's he looking for, JD? We want to write down the equation. Although I think the word you were thinking of, Mario, was formula. Okay, we want to write down that formula. M equals Y2 minus Y1 over X2 minus X1. Okay, and then we'll sub in. Okay, let's see, who haven't I heard much from? Rimmer, can you sub in for us, please? Good. Good. And what is 3 minus 2? Good. Very good. So the slope is 1/4. Okay, we sub 3 in place of Y2, 2 in place of Y1, 4 in place of X2, 0 in place of X1. We end up with 3 minus 2 over 4 minus 0 is 1 over 4, 1/4. Okay, what about B? What about the y-intercept? Tyler, what about the y-intercept? Where does this function cross the y-axis? At 0, 2. Okay? So what's the number there that we're concerned with? The 2. Okay, the b is equal to 2. So let's take all those pieces and let's sub those into y equals mx plus b. Hutch, can you sub those into y equals mx plus b? Very good. 1/4 x plus 2. And there's nothing we can really do to simplify that. Okay, we can't change anything to minus, can't change anything to plus. There's no fractions to simplify. So y equals 1/4 x plus 2 is where we finish off. All right. Let's keep going here. Let's flip over to the back. And let's look at number 4. Okay, let's fill the same directions. Find the equation in point-slope form. Not point-slope form. Slope-intercept. Point-slope is another conversation for another time. Okay, slope-intercept form. So we're always going to start the same way. We're going to pick a couple of points on the graph. Okay? Go ahead, B. Pick a couple of points on the graph. Okay? Very good. All right, let's label those points. Milius, label those points for us, please. I've got 0, -3, and 2, -3. Okay? There is no -2. We have 0, -3, and 2, -3. 2 isn't going to be x1, or excuse me, it's not going to be y1. Remember that the ordered pair always goes x, y. Always, always, always x, y. Okay? I know you're a couple pen strokes behind us. Make sure you get caught up. Do you need a pencil? Okay, well then get right. Okay, it'll help if you have the page turned over to the correct side. Okay, so what do I need to do to label the rest of these points, Seth? Okay. Good. Okay, she decided to make this x1, which meant she needed to change Milius's plan of having this as y2. Okay, x1, y1 have to go together. x2, y2 have to go together. Okay, now I've got the points labeled. Let's use that formula. M equals y2 minus y1 over x2 minus x1. Okay, Logan, can you sub in for me, please? Good. All right, Riley, what happens when we have minus a negative? Good. Comes addition, plus plus. And what's -3 plus 3? 0. And 2 minus 0? 2. And Riley, what's 0 over 2? Just 0. Okay? What about b? Where does this function cross the y-axis? At -3. All right, so Lauren, let's sub all these pieces in to y equals mx plus b. Or just 0. Plus -3. Good. Y equals 0x plus -3. Now, looks kind of weird though, doesn't it? Abby, what's 0 times x? 0. And what's 0 plus -3? -3. So we can just say we can get rid of that 0x plus, and just have y equals negative 3. Okay? That's what's called a constant function. Okay, there's no x. It's just y equals negative 3. It's every single ordered pair where y equals negative 3. So take a look at our 2 points. X was 0, y was negative 3. X was 2, y was negative 3. And any point on that line, regardless of what x is, y will be negative 3. Okay? All right, guys, we're running short on time, so I'm going to go through this next one kind of quickly, okay? But I want you to stay with me. Okay, first off, I need points, so I'll label. I have 0, 0, and I have negative 1, 3. Okay, and I'll call this one x1, y1, x2, y2. Okay, and I'll use the slope formula, m equals y2 minus y1 over x2 minus x1. I'll sub in m equals 0 minus 3 over 0 minus negative 1. Well, 0 minus 3 is negative 3, and minus a negative plus plus, 0 plus 1 is 1, which means the slope here is negative 3. B is where this function crosses the y-axis, which is 0, 0. And the y-coordinate of that point is 0. So that means our function becomes y equals negative 3x plus 0. But what happens when I add 0? Maddie? It stays the same. So I can simply say here, y equals negative 3x. Now what else can you tell me about this function, about x and y in this function? About the relationship between those two. Oh, it's defined. It's very well defined, in fact. Y equals a negative 3x. Stephen? That's not exactly a multi-step equation. Proportional. A straight line through 0, 0. It's y equals kx. It's a proportional relationship. Okay? So, to write the equation of a line in slope-intercept form, first we pick a couple of points and label them. Use those points to find the slope. Look at where that point crosses the y-axis and sub the slope and the y-intercept into y equals mx plus b. If we can simplify, we do.